Graphing this rational expression may be a bit challenging because we have this absolute value in the denominator. But we're going to first start maybe by looking at the zeros. So the zeros of this function are going to happen at x equals 0, and we're looking in the numerator here, and at x equals -1. Now this -1 I'm just going to make a note of because it looks like the denominator will have may have a factor that cancels out, and we'll take a look at that in a second. So we've got the zeros. We have a domain restriction that x cannot be equal to -1. Okay, because we're going to end up dividing by that 0 there. So again, we have this domain restriction. So this, although it's a 0 in the numerator, it's a domain restriction as well. So we have to be careful of that. So we have an absolute value. So it's going to be a piecewise function. So we need to make sure we work out the domains of this piecewise function. So the domain is going to be based on the absolute value being negative or positive. So for x values that are less than -1, we know that we're going to have a negative domain. And for x values that are greater than -1, we're going to have a positive domain. And at x equals -1, we're going to have a restriction. Okay, so that's going to be our 0, and it's a restriction, so neither of those can have that as a part of their domain. So there's our domain. We're going to need to write a piecewise function. Now, we want to simplify this expression because it looks like it has common factors, but we should factor the x cubed plus 1. And that is actually a sum of cubes, and there's actually a formula for that. And there's actually two formulas. One is for the difference of cubes, and another one is for a sum of cubes. It's nice to know these formulas. However, if you don't know these formulas, we can always work them out by breaking down the polynomial. So I'm going to use a formula since I have it. And I'm going to rewrite this expression. So I have x plus 1 in the numerator. And in the denominator, this gives a factor. Our sum of cubes becomes x plus 1. So that's our x plus y part of that formula. And then we're going to end up with x squared minus xy. So it's just going to be 1x plus y squared, which is just going to be 1. So there's our factored form. And we can see that in our factored form, we are going to have those x plus 1's cancel out. So they may not necessarily give us an asymptote. In fact, they probably won't give us an asymptote, but we really need to know what's going on at that point. So let's write our piecewise function then. Our f of x then needs to be written as a piecewise function. And for our piecewise function, we're going to have the positive and negative domains. Okay, so I'm going to start off with a negative domain here. And those are going to cancel out here. So I'm not going to include that in part of my function. So I'm going to end up with x in the numerator over, and if it's negative, we need to make sure that that denominator is negative. So I'm going to end up with negative x squared minus x plus 1. So because it's a negative domain, I need to use the opposite version. And I'm going to just pop that negative up to the top just to keep better track of it. And the domain of this is for x is less than -1. And the restriction at -1 that I'm keeping in mind. For the positive version of this, I'm going to have x over, we're going to cancel those x plus 1's, and so it's just going to be x squared minus x plus 1. And the domain of this is going to be for x is greater than -1. Okay, so this is our piecewise function. We need to check for continuity here. So I need to check for continuity by just plugging in the limits here. I can do this formally, and I can do this informally, but I'm going to choose to do this one formally here. So from the left-hand side, we want to know what's happening as a limit. So limit as x approaches the restricted value of -1 from the left-hand side. What are we going to get? So we're going to end up with, I'm going to just write the whole expression in. So when I plug that in, I'm going to end up with 1 over, and this is going to be 1 plus 1 plus 1, so it's going to be positive 1 over 3. So the limit from the left-hand side is going to be positive 1 over 3. I'm going to start putting these coordinates in. So from -1, from the negative side, it's going to be equal to 1/3. I also am going to put my 0 in here. So at 0, I know I have a coordinate at 0. Okay, so I've got a couple points there. And now I'm going to do the limit from the right-hand side to see what's happening at that restricted value of -1 from the right-hand side. So the limit as x approaches -1 from the right-hand side, I'm going to put into x over x squared minus x plus 1. So plugging -1 into here, I get -1 in the numerator, and this becomes, again, 3 in the denominator. So I've got a coordinate at -1 from the positive side is going to be equal to -1/3. Okay, but we know that it's at that point there's a restriction, so it's actually a hole there. So just drawing in these points from -1 from the positive side, I'm going to end up at -1/3. So maybe somewhere about, I'm going to draw it right about there. That's from the positive side. From the negative side, I'm going to have a coordinate at positive 1/3. So maybe somewhere about here. I think I need to move that other coordinate down a little bit. It's going to be right about there. And from the negative side, it's going to be approaching like that. And then I'm also going to draw my 0 while I'm at it. So there's my 0 coordinate. Okay, so now I have some points going on here. I've got my piecewise function. I've tested the endpoint or where they join to see for continuity, and there's definitely discontinuous because from the left side, the limit is different from the right side, and we have established there's a hole there as well. So I'm also going to do a limit for the asymptote. So let's take a look at the horizontal asymptotes as x approaches infinity of f of x. Well, we have a higher degree in the denominator, so that means that this is going to go to 0. And from the left-hand side as well, as x approaches negative infinity, since the degree in the denominator is bigger, it's going to go to 0. So in both cases here, we have a horizontal asymptote happening out here. So we've got a bunch of pieces here. So what we need next then is we're going to check for min and max points using a derivative.